All right, good evening. Today marks class 5 of FOP, and today we're going to be covering the a Python crash course. It's going to be a very basic introduction to Python. Just for the record, can I get a show of hands of how many of you guys have used Python before? Now, how proficient would you say you are?
I just took a class in college for it. I'm all right.
Okay, yeah, you're going to come to realize that Python and JavaScript share a lot of similarities. So if if you've written in JavaScript, then it shouldn't be too big of an issue to start writing in Python. Some stuff will be a little bit different. So overall, it's mainly just syntax. But the beauty of Python is that it's very user friendly. Um, so it's nothing too crazy. Um, it's very Let me know if you guys hear any like yelling in the background. If it's too crazy. I have a 2-year-old, so he likes to run around and throw stuff and hit the dog. So just fair warning for that. But yeah, so it's gonna be very easy to pick up. Python is known to be very user friendly, um, so it shouldn't be too hard. The entire lecture today is gonna be a code along. So make sure that you guys have your VS Code open and you have an empty Python file ready to go. Uh, as I mentioned to you guys before, coding, unless you actively code along and stuff and put things on your computer screen, you're not gonna get better at it, right? So we'll go slow enough today to make sure that we can all just like code along and practice the syntax and running it in our terminal for us to feel comfortable with it to a certain extent. All right. And throughout the today's lecture, we're gonna take some tactical pauses just for you guys to take a couple minutes to try out some small problems, and then upon the time frame, we'll come back and reassess the question, and we can code along with it to see how we did it and whatnot. So let's go ahead and get started. Can I get some nods if you can see my screen? All right, done. All right. So lesson 7, Python crash course. It's gonna be very basic. Uh, it's gonna be very similar to like your intro to coding. Very simple stuff, nothing too extreme. Just showing you the similarity between JavaScript and Python, and getting you to start putting some code on your screen. All right, so what is computer science? Computer science is big, and it's more than just programming computers. It includes subdisciplines like bioinformatics, cryptography. My bad. English is my second language. Uh, networking, security, robotics, AI, and many more. Uh, disclaimer: I don't have a degree on computer science, so I'm not an expert at this. But that's why we're all here, right? Um, what links all these disciplines together? It's gonna be a pattern or algorithm on how to transform information, right? So translating the science of information into many language. We learn programming language so we can express our algorithms. We will learn Python this week. So overall, the languages that we have is they're at the end of the day, they're just instructions, right? Uh it's very detailed instructions in a way that the computer, is formatted in the way the computer can understand you. That's all it really is, all right? So just very detailed instructions in their language. So what is an algorithm? All right, it's a pattern for how to manipulate and transform information. Uh, we call it a pattern sometimes because it must work for all cases of the problem and not just one specific case. You guys are gonna come to realize that uh, software development uh, and programming is different than computer science. Uh, they're very different. It's one thing to be able to like make a program and code and it's different to be working with algorithms. Algorithms themselves are going to be their own beast. Um, and I'm sure you guys already started getting a taste of it when working with, was it Code Warrior? I believe is what is introduced to you guys for the pre-work. And then if you've used LeetCode, same concept. A lot of these, uh, problems they're all algorithm based, and just because you struggle with algorithms does not mean you can't code. And you come to see that once you start building applications. We call it a pattern sometimes because it must work for all cases of the problem and not just one specific case, right? So that's talking in regards to ensuring that we take all the edge cases, right? And you'll get a better understanding of it once we start coding. A step-by-step set of instructions for accomplishing some task. Okay. What is a computer program? An algorithm that expressed in some specific computer language. We'll be writing algorithms or instructions in Python this week. Um, Today will be the Python crash course, and then you guys get access to the schedule. I don't know if you guys can see that I updated the schedule for this week. Do you guys have the slides? Okay, good. Right, you should be able to see that today with the Python crash course, and the next incoming day is going to be classes and objects. Um, it's all going to be written in Python. So you guys will get more than enough practice with Python this week. So don't stress today if you struggle to pick up the language or the syntax. All right, so running Python locally, you need to have Python 3 downloaded on your machine. This should have been taken care of during um, the install phase. I know Guillermo said he did like install phase for you guys during your weekly checkups. Is that correct? Does someone not have Python installed? Okay. I think I can see everybody's cameras. Okay. So I'm asking again. I think I missed a couple cameras. Ever has it installed? Good to go? North, south, east, west? Awesome. All right. Um, so just as a reminder, I don't know if you guys even tried it yet. On the right side, you can see a little code snippet here. This is how you're going to run your Python files, right? You're going to type into your terminal Python, and then you're going to type in the name of your file, right? Here we see that the file name is called index.py. So if it's a Python file, it's gonna end with .py, right? Very similar to how like if it's HTML file, .html, JavaScript.js. Right, same concept, but only thing different is you have to write Python in the front of it. Here it says you might need to run Python 3 name of file.py. Part of the install phase, I think there's a portion that tells you to change like the name of how you call Python. So instead of saying Python 3, you should be able to type in Python. If when typing Python doesn't work, try Python 3. You probably didn't do it exactly correctly, or you might have missed a step. It's no biggie. It's not deal breaker whatsoever. It was just to make it easier for you guys. But Python 3 will work just as fine if it doesn't work. All right. So follow along exercises and get and use your input. So let's go ahead and pull up my VS Code here real quick. I'm going to move the slides to my left screen so I stay on track, and I will code along with you guys. Um, okay, so we're working on lesson 7. I'm going to make, I'll just make a new folder. Practice examples. Uh, so Python is going to be written in snake case, right? Do you guys know the difference between snake case and camel case? Right, so we're working with JavaScript. We initiated the name of our variables in lowercase, and then every word that came afterwards will be capitalized. to symbolize like the camel's back, right? Python, very similar to what it's a snake. We work with snake case. So between every word, we're gonna put an underscore there, right? And that's gonna be the way that we write in Python. Um, so now it's not mandatory. Will it still work? Obviously, right? It's just like common practice of how you type whenever you're working with certain languages. It's not a big issue. The only time it will really matter is once you guys start working in a real job. They're gonna write code in a certain way, and it's gonna be up to you to make sure that you adapt to the way they write code. If their common practice is to write all in snake case or camel case, then you would adhere to those rules, right? So that's all it is. So we're gonna start off practice.py. Make yourself a new folder, all right? And we're going to try to receive input from the user, right? So the way that we receive input is, by the word input. So the way we're going to do it is we're going to save it into a variable, and we can do favorite food is equal to, and then what we're going to save it to the variable, we're going to type in input. All right, what this is going to do is when we run our file, the input command is going to prompt the user for input, which will allow us to type into the terminal, and whatever the user types in will be saved into our variable favorite food. And this is how we receive user input. So inside of input, we can ask the user a question. What is your favorite food? All right. So once our terminal asks or our program asks our user, what is your favorite food? They're going to respond. It's going to save the response into our favorite food. And we're going to want to print that out so we can visualize it. Very similar to JavaScript that we do console.log to see in our console different type of input. Python has something very similar. For Python, it's print, right? As you can already see, compared to JavaScript, it's a lot easier friendly, more user friendly. It's very straightforward. We want to print out the answer. So it's going to be print, right? Print parentheses. And inside print, we're going to do what we want. We're going to give it whatever we want to print. Here, I'm just going to go ahead and print out the variable favorite food. Down into my terminal, I'm going to call for the file, type it in Python, and then the name of the file as previously discussed. I am not in the right. So okay, so what is this telling me? It says can't open file, and it's showing me the path of my file. Right
Yeah,
here,
you're in the wrong direction. You're not in the right place.
I'm in the wrong direction, right? So essentially I want to go into practice examples. So I'm going to CD my way in there. And now I am working in the right area. And now I can call my file. All right, so once again, Python practice.py is going to run my program. And it's asking me, what is your favorite food? I'm going to tell it tacos. All right, just like I program the computer to say what is my favorite food, it also going to respond on line 3 by printing favorite food. All right, very plain and simple. Everyone with me so far? How we ask the user for input by using the command input and then printing out what we want. All right. Let's try something else. So we can print variables, but we can also print out strings. All right. In our print, we can do something like your favorite food. All right, that's gonna be our first string that we're going to print out. And then we're going to concatenate the response from favorite food with this string. So we did your favorite food space, right? Plus our favorite food. Your favorite food is and then we can also do plus and then a period. All right. So we're gonna concatenate these strings together. So your favorite food is space. We're going to add our variable in there that we saved, and it should return a different sentence. So we can do all that in print. What is your favorite food? Tacos, and it responds with your favorite food is tacos, right? Very simple, very basic. Still with me, right? No loss. Awesome. So that is how we receive user input and print stuff on our console. Now, the next thing we're going to cover, it's going to be floats and integers. So we just saw right now, we saw strings, variables, how to receive user input, and how to print it out in our console. Next thing we're going to cover is going to be how we do this. Is it? It should be. Geez, I forgot how to comment stuff. I haven't used Python forever. Oh, I'm dumb. Yeah. So we want to use we're gonna do ints and floats. All right. Now floats are essentially decimals, right? I don't know if you guys ever heard the term floating decimal points. All right. Very similar concepts, user friendly. Floats are going to be your decimal, right? So decimal is going to equal to float. And we're going to wrap our number. And we're going to give it the number 5, right? So by wrapping our number, we're going to change its type into a float. So 5 is currently an integer, and we're going to change it into a float, which is also known as a decimal. And it should convert it into a decimal format. So it should return 5.0, right? Something that isn't a decimal, you don't need to do this because we know it's probably going to be the default is going to be an integer, but we can still wrap it just to ensure that very safe typecasting. So decimal, not decimal, and we're able to print these out and see what decimal and not decimal return to us. And you're going to see that one should return a decimal format and one will be integer. All right. So the way that Python uses decimals is by the word float. All right. So float refers to decimals and for integers. Pretty straightforward. Same thing as JavaScript. Does anyone have any experience with Java? Not JavaScript, Java. No? Java gets very confusing. It uses decimals, big numbers, like big integers, like it gets very confusing. Python's very user friendly. Okay. Still with me? Everyone calling on? Moving forward. All right. So next thing is going to be strings and concatenating them, right? And doing some like string interpolation. So we already I already showed you guys a very short and quick example of what that's going to look like. Here's going to be something different. So we're going to do, we're going to say no more is going to be our variable. And we're going to say this string is. We're going to get a new variable and we're going to save fancy. One thing I do want to talk about real quick, you might notice that we're not doing let normal equals or const or var how they used to do it and whatnot. We're immediately just naming what we want to name it, and that's what's different about JavaScript and Python as well. You don't have to say let or const. You could just go ahead and declare what your variable is and assign it its variable. So that's cool stuff about Python. So don't worry too much about it. If you're confused about that. Next, we're going to print out. We're going to do normal plus empty space plus fancy. Let's see what that returns. All right. This string is fancy. So very similar to the previous example we just did, we were able to concatenate both strings together with space, we can do string interpolation. And the way we're going to do it is by using the F string. F being for like format, right? We're going to format our string. And then we're going to use our, unlike, if I'm correct, you want to double check. Yeah. So unlike JavaScript, I believe JavaScript, we use backticks. You don't need to use backticks here. All right. Here you can use single quotes or double quotes. All right. As you can see, when I press the backticks, it's already giving me an error with the F. Right. So unlike JavaScript that uses the backticks, here you're going to use F to start the formatting. To let it know that, hey, I'm about to format this incoming string. And then you're going to open it with either single quotes or double quotes. Does it really matter which one you use? No, not really. Just make sure that consistency, right? Same thing with everything else you do, like naming conventions. You want to be consistent with your naming conventions. Same thing with the whether you use single quotes or double quotes and what everybody else that you're working with uses. The only thing to take into account when knowing if you're using single quotes or back quotes, where does it matter? Is if your string uses like a quotation mark, like that's, or that is to show him or to show ownership. You know how you use the quotation mark and then the S. If you want to do something like that, then you would have to essentially let it computer know that it's not part of the string. And I'll show you guys in a second how to do that. So here, what we're going to do is we're going to put normal and fancy together. Using string interpolation, we're going to do it by using curly brackets. All right, so we use the F to format it, and then we open up our string with whatever quotation marks we're going to use. And then whenever we want to put a variable in there, we're going to use the curly brackets, and we're going to call it normal, right? Which holds the string this string is, right? Then we're going to put a space because this overall is its own string. It's just that in the string, we're adding a variable in there. We're using the curly brackets to let the computer know, hey, like this is a variable. All right, it's not a string, it is a variable, and we want whatever is inside this variable to be inputted into our string. So we're able to put that space, and then we can call fancy. And this should return a very similar result as line 17. All right, line 17 and line 18 did exactly the same thing. You're able to do the same thing in JavaScript. I'm sure you guys have some similar experience with it. And this is just how you do it in Python. All right. Are there any questions up to this point? As I was talking to you guys before, how would you use a word that uses quotation marks? Then you want to let it know that that quotation mark or that symbol you're using, you're going to use the backward slash or forward slash. I guess whoever you talk to will tell you one or the other, forward or backward slash. I don't know which one this is exactly, but you want to use that slash right here. And that's going to pretty much opt it out, let it know, hey, this is not part of the string quotation marks. This is the string itself. And that would allow you to use that specific quotation mark. All right. Just so you guys are aware of it. And it should be something similar to if you wanted to use the dash itself, you could do that. You're letting the computer know, hey, I'm using this. This is not a backslash. Does that make sense? Am I losing anybody here? You're pretty much just letting the computer know by putting that backslash next to it that this is not part of any command or whatever. This is part of the string itself. I can get rid of this. And that takes care of that part. All right. Now, next one is going to be casting to string in integer, right? So we're going to do num to string. And in here, we're going to add a number. but we're gonna convert it from an integer to a string. And to do that, we're gonna wrap this bad boy up. And outside of it to the left, we're gonna put str for string. All right, we're wrapping it with a string to change the type of the number that we are using, right? Now, to convert it from string to integer, you'll do something similar, string to num. All right, let's just mind to make a mention, I'm calling it. And you will wrap it with the int. And here you would put the string, right? So the default, if you were to put a number, it's going to be an integer, unless you specify that it's going to be a string. So as you saw here, the moment I put the 45, it automatically recognized it as an integer, which is why we're using the string to convert it. We're wrapping it with a string. Here, I declared it as a string right off the bat, but I'm converting it with an integer outside of it. Okay, and then we're able to print out num to string, and then print out string to num, and it essentially does this. Can you see what it's doing? Not exactly. So how do we know if one is a string and one is an integer? Well, that's very simple. We're going to use a command, and JavaScript has something very similar. I believe it's type of, but here it's just type, right? So if you want to print out num to string, inside here, we're going to wrap this variable with type. And what that's going to tell the computer is print out the type of what's inside this parentheses, which is going to be num to string. And we're going to do the same thing to string to num. And when we print it, it's going to give us the type of that specific variable, right? And it tells you here class of string. This is a type of class of integer, right? And that's how we're able to see if is this a string or an integer, right? JavaScript has something very similar. As you can tell already, like they're very similar formats. Just Python's a little bit more simpler. It just takes type. Cool. Any questions so far? All right, moving along. So this is I'm trying to label these for y'all. Let's go with string and in case anyone asks for this or whatever, you guys are doing it. String, okay, and this was oh type conversion. All right, next thing we're gonna do is gonna be booleans. You guys remember correctly, booleans is whether things are true or false. All right, so there is a difference with JavaScript and Python when it comes to true or false, or essentially your booleans. I believe, if I remember correctly, JavaScript does not use capital letters. For Python, it does. If I were to just put true, it's not going to take that. As you see, it's going to recommend you the very first one for it to be capitalized. Right, that is the only difference between true and false when it comes to JavaScript and Python. And this is false. Um, let's break that out actually. Print. We're gonna do type. This is true. This is true. Print type. This is false. All right, so class Boolean. We can even print out print this is false. Print this is true. True and false. You see it printed out for us. If I were to put this bad boy as true, not going to work. All right. Damn true is not defined. Did you mean true with capital letters? All right. That's the only difference between Booleans and Python compared to JavaScript. You guys know how to automatically comment out everything, right? The command for it? No? It's going to be for Windows, control / or wherever your question mark is at. And that should automatically comment out anything that you highlight. All right. So other cool stuff that you might want you can do is you can highlight stuff, press Alt, and while pressing Alt, you can use your arrows to move whatever you have highlighted up and down your screen. Just some cool stuff you can try out. Any questions before? Pretty plain simple. All right. Arithmetic and ABS. So, very similar to JavaScript, we're going to do addition first. So my sum is going to equal 3 plus 4. That's how it's written. Straightforward. Both these numbers are integers, right? That's going to be the default value. Next one's going to be for difference. We're going to do 3 minus 4. That's going to subtract. If we want to multiply, we can do 3 asterisk 4. That will multiply for us. Next is going to be division, or I guess quotient. Quotient, and this will be 3 divided by 4. One thing to note is whenever you divide, your answer is going to be a float by default. All right, so just keep that in mind. The 1 / will give you a float, right? Decimal. And then next is going to be our ABS, so absolute value. And we can do ABS in -5. What does that mean? Essentially, by wrapping it with the ABS, it's going to return to you the absolute value of it, no matter if it's negative or positive. And we can print that out too. We'll print all these out. Print my sum. Print difference. Print product. Print quotient. Print. Right, so addition, 3 minus 4 give us -1. So subtraction, we multiply 3 times 4 give us 12. As mentioned before, division will give you a float. And then absolute value, by wrapping it with ABS, it'll return you, no matter whether it's negative or positive, the absolute value of that number. If you want to get a non decimal, believe it's 2 /. That'll essentially, it works like floor. It will give you the rounded version of that, of your answer. Yeah. So you see here, by doing 4 divided by 2, which is 1, it'll give you the float answer. If you want a rounded version of it, it'll be with 4 divided by 2. Now, what did we do? 5 divided by 2. T rounds down. So 5 divided by 2 should be 2.5, but it rounded down to 2. So that's our floor version. Sorry, my kid's yelling. Gotta go put him away. All right. Next. Okay, next slide was floor division. Oh, modulus. So I'm sure you guys probably use stuff like this in JavaScript already. The modulus operation is done with the percent symbol, I guess is what it's called. Let's go ahead and comment this out. Over it from the tick and yes. You guys hear my kid in the background now? Good. Sorry. It's gonna be, so we talked about floor and modulus. So as mentioned before, give me a second. Sorry.
Yo, I know.
My
Hey,
kid's
Roger.
What's up, brother?
I just had a quick question. I know Guillermo went over. I'm totally just blanking on it. How are you running? How are you printing everything, like running it in the terminal without just retyping the Python practice py command?
Up arrow. So up arrow will give you your last commands.
Okay.
Yes, sir.
Sweet. Thank you.
Yeah, don't hesitate to ask any questions you guys have. Is that the only question I have right now? Anybody else? Sweet. Yeah, so as mentioned before, our floor, if we were to do 5 divided by 2, and we printed out floor, it'll what the heck? Oh, what am I doing? My bad. I'm with a blonde in my afterlife. So 2, right? So floor, now modulus. Modulus essentially what it's gonna do is gonna give you the divisible of whatever you give it. And I'll give you an example. So if we were to do 4 modulus 2 and we print out modulus, what do you think is going to give us? It's going to give you the remainder of what this does. So essentially, it's going to divide the 4 by 2, and it's going to give you how much remainder there is. So 4 modulus 2 is going to be 0 because 2 fits in 4 perfectly. But what if we're to do 4 modulus 3? It's going to return us 1, right? Because 4 only goes into, and 3 only goes into 4 once with a remainder of 1. This is a very easy way of figuring out if something is even or odd. You can get your number and the modulus 2, and if it returns 0, then you know it's even, right? That's a very easy way to check if stuff is even or odds for like those basic leak code problems when you're trying to identify whether, return all even numbers or whatever. Very simple. All right. Exponents and concatenate. So exponents, we can multiply by using one asterisk, but if we want to use an exponent, all right, so what are we going to do? 3 to the power of 2. All right, so exponents and concat. I don't know why this put twice. I might have to change this up. Oh, I see. Okay. All right. So if we want to do something like power of 2, right? And we want to use exponents. The way the exponents is written is going to be, let's see, 3 to the power of 2. That, what do you think will return? Basic math, it should return us 9, right? Now, for concatenating, we'll do it in a bit. So let's check what power of 2 gives us. It gave us 9. So what does that mean? It's going to multiply this by 3 by itself. So it multiplies it by itself, right? So 3 to the power of 1 essentially is just 3, right? To the power of 2 is going to multiply by 3 once. So 3 times 3 should give you 9. To the power of 3, you should multiply by 3 a third time, right? So that's what, just basic math class. That's what we're trying to do here. That's what these exponents are. Now, so that's exponents. If we want to concatenate different things, we can. We can do a list. So for lists, pretty straightforward. It's gonna be with your brackets, right? If you want to make a list, you just write down the name of the list. My list 1 is equal, and then open and close brackets will initiate your list, and we can put stuff in our list. And we can do my list 2 is equal to 4, 5, and 6. But what we can also do is we can concatenate these lists together, right? But we can do something like print my list 1 plus my list 2. And what this is going to do is going to print out both those lists together, as you just saw. Right? So we see here 1, 2, 3, and then it added the 4, 5, 6 into it. So we can concatenate different things like that. We can essentially do the same thing with strings. So string 1 is equal to hello. String 2, how are you? And then we can print it out. Print string 1 plus string, oh, typo, string 2. And it would essentially concatenate both strings together. There's no space here, so it doesn't do that, right? Same concept, it does that for you. Very straightforward. Okay. So that's exponents and concatenation. We can also use the plus and equal syntax in Python to concatenate strings or lists. So I think Donnie did it once. We can do string 1 plus equals string 2. By printing that out again, we can see it concatenates the same thing. All right. So we got that one string which said hello. We did plus equals, and it added that string to it. Same manner. Okay, cool. All right. All right, so common Python messages, obligatory messages, and debug code is very important. So I do not expect you to be able, and I don't think anyone's going to expect you to be able to read much of your error messages for like the first month, almost even 2 months even, of your error messages. And that's okay. At first, these messages seem very foreign, like, the stuff it tells you. But the more you see the errors, the more you will start to understand the the issues that it's linked with. Here's your more basic and common errors that you will see in Python. EOF is going to mean end of file. And it probably just means that you forgot a parenthesis somewhere. Name error, you called something before assigning it, right? So calling a variable doesn't even exist. Syntax error, make sure you check the spelling in your file. You probably just mistyped something wrong. And then type error, you're trying to perform some action on the wrong data type, right? Trying to like multiply strings or whatever. These are more common mistakes that you will encounter. And then I discussed prior to this class, like when we mentioned AI and stuff, if you struggle reading these error messages, you can't go wrong with just putting that error message to ChatGPT and asking explain this error message to you. It might take a couple tries before you understand it eventually. Before you know it, you don't even have to do that anymore. You'll know what these error messages mean. So ChatGPT can help you, or you can also just look it up online. But yeah, these are your more basic ones. Okay, so we got Python students practice coins.py. That's going to be in the repo. You guys should all have a link to that. If you don't, let me know. But before we even do that, it's 6:20. Let's take a break before you even start this. Let's come back at 6:30. Take a 10-minute break, and then we'll continue off on this. Let me share my screen real quick. We just started the Python crash course. And we got to slide 15. We're doing coins.py. So if you can just pull up your VS Code and start working on that, we're getting 5 minutes to work on coins.py. And then after the 5 minutes, we'll reconvene and talk through it and whatnot. So do you have any questions, whatever, Kara? Do you have like Python installed on your VS Code?
Yeah, I'm all set.
Okay, awesome. Yeah. So time is 6:32. Let's take the next 5 minutes and come back at 6:37 after working on coins.py. Awesome. Was everyone able to get close to being finished, or did y'all finish it? Yeah. Okay. Awesome. Yeah, we'll walk through it. If at any point you guys have any questions, don't hesitate to stop me and ask. And then after we're done, then if one of you guys want to demonstrate a different way that you guys did it, by all means. Let me go ahead and share my screen. Can you guys see my screen or no? My VS Code?
Yeah, it's good.
Awesome. Okay, yeah, so it says write a program that asks the user for an integer number of cents from 0 to 99 and outputs how many of each type of code will represent that amount with the fewest total number of coins. When you run your program, it should match the following format. Please enter an amount in cents less than $1. It should be able to receive that integer and then return us your change will be, and then exactly that format, right? You may find the model operator useful. You may not use any loops. Yeah, so let's try it out. So what's the first thing that we want to do here, essentially? We're gonna
Establish the
want to,
user input.
yeah, we're gonna want to prompt the user for some feedback. So we're gonna want to do we're we're gonna declare a variable. We're gonna call it cents because whatever the user gives us, it's what's gonna be our cents amount. And we prompt the user by input, correct? So in the input, we're going to ask them our question, which is gonna be, please enter an amount in cents less than $1. I'm gonna put a colon here and a space to just to format and make it look pretty. And we know that we're gonna want this to be an integer. And just to ensure that whatever we get from the user is an integer, we're going to wrap this bad boy with int, and that'll make sure that this is a number. Okay. And just to ensure that this is working, we want to look at it. We can call it, please enter an amount in cents less than a number. We can do 87 like there, and awesome. So it's printing it out. Cool. Student what it should be doing. Now, the next thing we want to do is we want to start first and foremost, we want to check to ensure that what we got was a number within the proper format. So we're going to do an if statement. It's going to be if 0 is less than or equal to cents. And then we're going to do that cents is going to be less than equal to 99. Then we're going to execute, this, whatever. All right, we're not going to actually do this, but we're going to actually make it do what we want. Else, we're going to want to tell the user this is not a valid amount, right? Just in case they put -6, or like something crazy like that. We can just do something like that. That's how essentially we're going to want to format our algorithms, right? So as mentioned before during the slides, we want to deal with these edge cases. So to ensure that the user knows what we're putting here, we're going to ask for something between 0 and 99 and double check that it is that. So now that we have that, we can actually put some logic in here. And what's the first thing that we want to do? We want to check between quarters, dimes, nickels, and pennies. We have our initial number. So we can try to, it says, represent the amount with the fewest total number of coins. Essentially we want the smallest amount of coins. So it would be easier to knock out all the quarters first. So to find out how many quarters this is going to take, we want to declare a variable. We're going to call it quarters. And here, what we're going to do is we're going to grab the amount that the user gave us. I'm going to divide that by 25, which is going to be the quantity for quarters. And if you guys remember correctly, using 2 forward slashes is going to work very similar to how floor works. So it's going to round down our number to the nearest whole, which if, for example, if we were to give it 80, it should return us, 75 or something like that. Right, because we're dividing it by 25. Yeah, so cents divided by 25. Now let's just make sure that it's doing what we want it to do. All right, so we can do 80. Yeah, so it took cents divided by 25 and it ran down to the nearest one, but it's only 3. But what if we were to do something like 30? Right? It'll run down to 2, right? Because it only goes to twice and it's running down to near. So, okay, cool. Then what we want to do, if we were to give this 87, it divided by 3. So, yep, it goes into 3 times. So we know how many quarters it's going to take. But now, after we get the quarters, we want to ensure that we eliminate that amount. So the way we're gonna do it is we're gonna do cents. We can do modulus equal, or we can keep it even simpler. We can cents equals to cents modulus 25. I'm a very visual person, so let's see how that works. If we give it 87, it prints out 12. So if we do 87, which is what cents gonna have, modulus 25, it should give us the remainder after it gets to 25. So we tell it's working. It returned is 12. That's how much it remained after it divided it by the 25. So that's working. But as you guys saw earlier, we can also do something as simple as cents modulus equals 25. I believe they should return the same answer. Yeah, right. So either one or the other would work just as fine. It's very similar to the plus equals that we saw earlier. Are there any questions at this point so far? All right, cool. So we took care of the quarters. We know what the quarters is, but now we want to see how many of the dimes are going to fit into our example. And the way we're going to do that is very similar to how we just did it for the quarters. So we can go ahead, remove this. We know this method is working so far. Since it's now formatted, we've accounted for the quarters. So we're going to do dimes is equal to cents and modulus 10. And then after it accounts for the dimes, we want to remove it. And that'll take care of dimes. Next will be our nickels, which should be equal to cents modulus 5. That should return that to us. Let's ensure that it's doing what we want to do. Cents. Okay. Right. Cents. Is it working so far? Yeah, so it did that. Awesome. We can do pennies equal to cents modulus. How do we do this? So we do nickels equals cents modulus 5. Cents modulus 5. We can essentially just do pennies equal to cents 5. And that should print out. Let's see what pennies has. 7. Yeah, it should be percent. Okay. Yeah, it should be the remainder of it. So we got that. Format it all. Now we can do print. What was it? We're going to do some string interpolation. We can put your change will be. All right, as mentioned before in the class, how do we do it? We put our curly brackets. I'm going to put our variables in there. We're going to want our quarters. We can put our quarters there, but we have to have Q to the left of it to format it. Okay. Next gonna be dimes. All right. Next gonna be nickels. And finally, our pennies. And that should return us what we want. Here, let's try that. 37. Okay, so in return, your change will be quarters 3, dimes 1, 0 nickels, and 2 pennies. Pretty straightforward. We use the modulus to give us the remainders of what it would have. We use essentially the floor division method to get how many it went in there, without giving us a weird float like the 1 / would give us. And they just did some string interpolation, pretty much all the basic stuff that we covered today in the initial part of the PowerPoint. Are there any questions up to this point? Did anyone do this differently that would like to demonstrate there?
I did it a little differently, Roger.
Yeah, let's go ahead. Let's show us, please,
Okay.
if you don't mind.
Um, you guys see it? Okay. Yeah, so instead of doing the modulus, I just continuously subtracted the like the previous variable from cents. So like quarters, set quarters equal to cents, and then floor 25. And then dimes is equal to the cents, which is the user input, the same thing. Minus 20 quarters times 25 minus the number of cents that many quarters would be, and then modulus 10, or not modulus, the floor 10, and then did the same thing for nickels, just sequentially down to get each one. But yeah, that's the only thing I did differently.
Yeah, different format, but essentially the same concept. Yeah, not bad. Did anyone not solve it that struggled at any specific point that would like to ask anything? Everyone good so far? Sweet. Let's go ahead and get back to the PowerPoint. All right, so that took care of the coins.py. Next is gonna be comparison operators. So I think we're good to go back to coding along with y'all. Yeah, all right, I'll code along with y'all. All right, cool. So back to the practice.py. Alrighty. So comparison operators. So these are very similar to JavaScript. I'm sure at this point you guys have already realized that JavaScript and Python share a lot of similarities. There are some small differences, but if you've learned one language, you can learn both languages. So it's not a big issue. So comparison operators, we have our num1 is equal to num1 is equal to num2. Right, so this essentially is going to check if these are equal to each other. If num1 equals to num2, very straightforward. We have our num1 is not equals to num2. This would check if it's not. We have num1 is greater than num2. Num1 is less than num2. All right, we're comparing to see which one is greater or less than. Then we have our greater than or equal to, which I used earlier to num2. Num1 less than or equal to num2. All right, so pretty much just opposites of each other. And then we can also test floats for equality. I haven't really used this much myself, but we can do absolute. For example, if we were to get num1 minus num2, and then we can compare them. We can check for floats being equal or not, but I've never really had to use this. But I think all this is just comparing to each other, very similar to JavaScript, straightforward, very basic. So we won't spend too much time on this. Chaining comparison operators. So here is how we would essentially do it. Chaining comparison. So in JavaScript, you do x, let's say x equal to like 0, and then we would do the pipes, right? We would do pipes to see if we want to do or y is equal to 0, or z is equal to 0. You would use the double pipes method to check, do ors. And then if I remember correctly, we could do for, if we want to do and, you would do, what am I wrong here? I haven't used JavaScript in forever. So correct me if I'm wrong. Is the double ampersand correct?
Yep.
Where for JavaScript, it's more wordy. You would use essentially, let's say for example, if x equal to 2, you would do or. You deliberately type or. And then you could do y is equal to 2, or and then z equal to 3, or you would deliberately type or. And then same thing for ants. You could do, for example, like if it's 2 is less than x and x is greater than 7 or 8, right? You would type n, and that's how you would change that. You could also do it how I did it earlier, where you can just go ahead and do like 2 less than x and x less than 7 is one way you can chain comparison operators. Where JavaScript doesn't really let you do stuff like that. So a lot much user friendly in comparison to JavaScript. And this is kind of where you would get confused. Once you start working with both Python and JavaScript, you'll work with Python for a couple months, and then suddenly you have to start working on the front end. You're working JavaScript, and you confuse these different syntax, like the ands or the ors, or you go to declare function. And in JavaScript, we declare functions by typing in function, but in Python, it's different. You put def for def for define, right? And that's the only hard part when working with JavaScript and Python. It's just getting used to which one you're working with. And it doesn't get better by not coding. You'll get better over time. I promise you. So if you struggle with Python this week, don't worry too much about it. The more you code, the easier it will get. Comparing booleans. If boolean 1 is equal to true, boolean 2 is equal to false. If you want to compare booleans or whatever, you would do the same thing like before. Bool 1 and bool 2, right? Or you would do bool 1 or bool 2. Same thing. Another thing you can also do will be the not, right? So not bool 1. So if bool 1 is equal to true, and you were to put not bool 1, then you're essentially checking if it equals to false, right? Does everyone understand that concept? Right? So it's a short way of checking if something is false or true. Instead of typing like if bool is equal to false, you can just put not bool 1. If bool 1 is assigned to true, and you were to put not bool 1, then obviously you're asking if it equals to the opposite of what that's supposed to equal. This is just if you know what that variable is supposed to hold. Stuff like that, right? Yeah. Any questions so far? You can also do it with like other stuff, like not 17 greater or equal to 10. So if you're this would check whether 17 is greater or equal to 10. And if it's not, then it should equal false. Same concept, using that not method behind it. Just a shorter way of checking it.
I should. Is that the same as like just the exclamation point in JavaScript? Like if you have an if statement and you put the I forget
Yeah,
the
so
correct term for the
let's
operator,
say
but
num1 is equal to false. If not, how do we do this?
or it would be easier with true. If num1 equal true and then not,
Yeah,
because then you're dealing with like a triple negative.
if not, num1 print
Yeah,
hello, right?
right.
And we can, what is this? Uh, where's my practice at? Where am I at?
It's in practice underscore
Practice examples.
examples. Yeah.
Python practice. If num not one,
So if you change num1 to false, it would print.
yeah,
Right. Okay.
pretty much how we use the not for. You won't really
Okay.
need to use it too much, but it does help to essentially just compare.
Okay. Is
JavaScript
the
has its own format of it too. What's up?
I did have a question too on the equals, like num1 equals num2. Is that the only because like in JavaScript you have like the strict equality, which is both like value and type, and then you have two equal sign, which is just value. So like the letter one equals the number one with just two equal signs in JavaScript. Is that the same thing in Python,
I
or is it
believe
just
so. I think yes, I do believe so. We can check that real quick. If let's see, num1 is equal to let's say 1, num2 is equal to 1. You say if num1 is equal to num2, print yes. Else print no. So we can check it out. So yes, it does equal to that. But what if we were to do uh we do equals invalid
okay?
syntax?
Yeah,
So I guess
invalid
not.
syntax. Okay,
Yeah.
gotcha.
I guess JavaScript just likes to be a little bit more specific. There's pros and cons to both languages. The importance is to choose something you like and get good at it.
Yeah.
You have to be flipping between both of these. But if you can get really good at one language, then the other one will be easier to pick up. I promise you. But it's not. It doesn't hurt to know multiple language, especially if you're going towards full stack. You'll need to know both Python and JavaScript. JavaScript can do both essentially, but uh, different places will require different types of frameworks or different languages depending on what they use. All right, so data flow and if statements. So I understand this is very basic. A lot of you guys already know stuff like this because of JavaScript, but it's just part of the curriculum. So data flow and if statements, we can do something like num is equal to 12. And if num modulus 2 is equal to 0, right? We want to print essentially we can do num is even, and we could use else, but we can also use if we had multiple stuff. We can do print num is odd. If we had multiple stuff that we wanted to check, we're able to use something like elif. If num modulus 2 is equal to 0, print elif num modulus 2 is equal to 1, print something else, right? Elif num modulus 2 is equal to 2, print something else twice. All right, so if you want to print multiple stuff or you want to check multiple different comparisons, whatever, or there's different conditions that you want to check, you would use the elif, and you can finish it off with the else. But if you have multiple stuff, you would use the elif, where JavaScript uses else if instead, a little bit more delivery there. But that's how you would use for multiple conditions. Any questions on the if statements? Difference between Python and JavaScript would be if, we would open this bad boy up and then we would compare x equals to y. And then we open the brackets. You don't need to do that with Python. It's a little bit more straightforward. You can just go ahead and straight ahead and just start typing away on Python. You don't need to use that type of syntax with Python. You would just straight up type what you want to type. If x equals y. Brilliant. Yes. All right. Very simple. That's the only real difference between the formatting of Python and JavaScript is using those parentheses and curly brackets not needed. All you really need is that colon afterwards. Right? And vice versa, elif y equals to z. Right. And you just keep doing that for all the conditions you might have. You don't need those open parentheses, curly brackets. Very straightforward, very user-friendly. Easy syntax. Or while loops. So while loops, we have them in JavaScript. I hate using while loops personally. I don't know why I was messing my while loops where I ended up making an infinite loop. I suck with while loops. But while loops and how to use them. An example would be we can assign a variable called total score. Total score is going to equal to 0. All right, and we can do while total score is less than 100. Print total score. And then let's try that bad boy out. It'll be very simple. Oh, we didn't even see. I always do this. So while total score is less than 100, print total score, and then we want to do what? Total score. We want to ensure that we change it. All right. So what did we just do? We set a variable to 0, and we call it total score, and we did a while condition, right? So it's a while loop. Essentially, we say, hey, while this variable is less than this, while this is this, I want you to do something, right? And then after you do that, what you need to do is ensure that you change that condition or you increment or you decrement, right? Unlike JavaScript where you like have to do you could do syntax where you would do I is equal to 0, and then you do I less than 10, and then you increment it here, I plus plus, right? You would declare it, put the condition here, and then what you're gonna change, it's a little bit different here. All right, we would have to declare the while in the beginning, while score is less than 100. We want to do something. We want to print total score. All right, and after we do that, we need to ensure that we either we have to change something so it works towards that condition that we had set. Total score is going to increase by 1. I want to print that 100 so we can do less than or equal. And that will print up to the 101. You see here, it went through the entire while loop. It said while the total score was less than 100, it checked the total score. Hey, total score is 0. So I'm going to go ahead and print my total score. After it prints it once, it's going to increase that total score. It's going to go back up. And it's going to check that condition again. While total score less than 100, what's my total score now? It went up by 1, so it still meets that condition. Therefore, it prints it again. And it's going to keep doing that until it no longer meets that condition. Once it reaches it, it's going to stop. All right, and that's exactly what it did. So you want to avoid infinite loops like I did earlier. What did I do? I went ahead and I printed a total score right off the bat, and it immediately started printing out total scores, so a bunch of zeros. So does everyone know here how to stop an infinite loop if it happens in your terminal? Does someone not know? Okay, so if you do what I did, we'll go ahead and do that. It's going to keep printing zeros. You can see on the right side, my scoreboard is getting smaller and smaller because it keeps doing it. The way to stop an infinite loop is you're gonna press Control C, and it's going to cancel everything. All right, it's going to cancel running it, and it will stop it. Here we can see how many zeros. I'm scrolling and scrolling and just infinitely start printing my zeros because I never changed the condition. It kept going through that while loop because the condition was, hey, if it's not 100, I want you to print this bad boy. So it went through, it printed it once, it went back up to check it. I didn't give it a condition or I didn't change it at any point in my code. At no point the total score ever changed. So it just kept going through this while loop. So if you encounter that situation where you are in an infinite loop, easiest way of doing it is you just press Control C. I believe Mac is Command C. Don't hold me to it. I've never had a Mac. So but yeah.
just tried it on the Mac and
Yeah.
it was Control-C.
Okay, good. Yeah, so that's how you get out of an infinite loop if you encounter it. Other situations where you might put yourself in an infinite loop is by doing stuff like while true, print high, and at no point did you ever change it again. So this is a very common one. You know, while true or false, make sure that in your statement at one point it will reach that that condition where it's going to change. So that's where that works, right? I think the example in the slides is while total score is less than 100, total score is plus equals the input, enter your score for this round, and then we're gonna print total so far is equal to, we're able to put a comma after that string and print out the total score. And this is going to keep prompting the user score. Well, total score doesn't. Oh, I immediately gave it 100. My bad. So I gave it 50, right? I prompt the user for input, and it's going to keep prompting me until I reach that condition, which is my total score being 100. I sucked. I couldn't get a high score. My score is only 50. So he asked me again. This time, I still suck. I only got 51. And does it keep prompting me for, actually, never mind. It went up. My bad. I didn't pay attention to the condition I said. It's adding it, right? So afterwards, I did a plus equal right here. So it added that integer. So it's going to be adding it until it reaches a certain condition. But overall, my overall score did reach over 100. So it stopped it. Pretty plain simple. JavaScript has the same thing, just written a little bit different. But avoid infinite loops. Once again, while loops is while something has not met a certain condition, we want to do something. And then in that code, ensure that you put a condition for it to stop. All right, or you're going to end up with an infinite loop. And it's going to keep going to those loops. I suck with infinite loops. Hopefully, you find some good use for it. All right, next. So that covers the while loops, for loops. All right, so for loops, I kind of gave you an example of the for loop earlier with JavaScript. So how do we know which for loop to use? Do you guys know? When do you use a while loop as opposed to a for loop? Who can give me an example? It's not a trick question. I know some people have asked like, oh, how do you know what code to use or what to use or what methods to call? But just like your own thought process. When do you know when to use a for loop or a while loop?
I would say I want to use a for loop when I want to like deliberately increment or decrement through like an array or an object in a while loop while I'm just like looking for, while a condition holds true or false. I don't know.
Yeah, no, you're not wrong. Absolutely right. So for loops usually we do we do a for loop and we'll loop through like an array or a list, and that's because we know that there's a limit to that. We know that we want to do something for every single item in here, right? We know that we want to do it for every item with a condition, or a for loop with a certain quantity, right? So we usually have an idea of the quantity or what we want to work with or how much of it. It might not always be exact, but you have an idea that you want to do it to a certain extent. While loops is until it reaches a certain state, you might not know what that state is, but until it reaches it, you want to do a certain action. So yeah, it's all situational based. At the end of the day, there's no right or wrong answer. It's whatever gets the job done. Later, you'll find out there are some methods that are a little bit more effective than others. We'll start talking about space and time complexity. Then you'll start really realizing which ones you really want to use. But as of right now, don't worry too much about stuff like that. But that's just a little something to get you thinking about it. So, for loops. So, we'll do something very simple. So total score is going to equal. Actually, we'll do it differently. Let's create a list, right? So in Python, they're not called arrays; we call them lists. So we're going to create a list. This list is going to be called colors, and here we're going to put 5 different colors. We'll do red, red, white, blue, black, and purple. The way that we're going to declare a loop on Python is going to be very simple, very similar to JavaScript. You just don't use the parentheses or the curly brackets. You start with the for, and then you will do something that very simple, like the same method, the same way you in JavaScript you use like an I or an X to declare that item of where you want to name that item. You can do that here. So I'm about to loop through this list of colors. So I can call it color for color in colors, right? So you're going to essentially for X of whatever you're trying to loop through. So I'm trying to loop through this array of colors. So I'm going to put the name of whatever I'm trying to loop through. This right here, color, it could be anything for X in color, for I in colors, for dog in color. It doesn't really matter. Essentially, when it's looping through it, every single item is going to grab. That's what that is. All right. So for color in colors, I'm going to print out that specific color. All right. Whereas this JavaScript, it'd be for let I equal color. Or actually, it'll be a little bit more deliberate like that because you won't be able to deliberately grab the item. It will do something like I equals 0, I less than like what the length, right, of what colors is. Or you might even want to assign the length of what colors is. Let's say color length is equal to for Python is length, right? But I believe for JavaScript is length. You have to actually type out length. But here it's len. You would get the length of what that color is. Then you do while I is less than color length, and then you would do I plus plus, right? So you're not able to grab that item directly. You would usually do like colors and then put I in there so you can grab it by index. You don't have to do that essentially in Python. You can you do for color in colors, grab every single item in that list and it will just use that item. All right, so for color and colors, we want to print color, right? But if you wanted to make it a little bit more like JavaScript, then there's a way of doing that. And we use that with the enumerate method, right? So here we grab every single item. The regular for loop, the first thing it's going to do is going to grab the item. That's its default way of working. It's going to grab that item in that list and it's going to use that item to do something. But if we don't want to do that, we want to work with the index and stuff, we can do something like for index, comma, color, and enumerate. All right, this is the enumerate method, right? You would have to deliberately have to put enumerate around colors, wrap it, and what that's going to do is as it loops through your list, is going to grab or assign it its index, right? And you're able to print the index and color. So as it goes, it's going to do for the index and color, and colors enumerated, right? Enumerated, that's essentially how it's read. I want to print the index and color, and we can see here it print out the index and its color. So 0 red, 1 white, 2 blue, 4 black. If you were to try to do the same method while using enumerate, you're going to get an error, right? For index, color, and colors, too many values to unpack. It doesn't know what index is. Like what it knows what color is. By the way, it's this method is formatted in the way that it's always index first and then the item in the list second. So if you were to have done for color, comma, index, just know that this is still going to be in the this is still an index. You just named it differently. You just switched up your naming convention, so you might get confused. But be aware that the syntax for this is going to be index first and then that item. But yeah, so if you do this while enumerate, it's not going to print it out for you. It's going to be confused. So you have to do enumerate, and it'll tell you you'll get an error for it if you don't put enumerate. See, it printed out index, which is the color, instead of the actual index. So this right here, that syntax, that format, it's set in stone. You can't change it. Make sure that you're tracking which one is going to be which. So for index, color, and enumerate, for index, color, that's a do it. And that's how you can grab the index of whatever you're working with to make it similar to what JavaScript does. But if you don't do that, then you need to just be aware that you're going to grab that individual item. Is everyone with me still so far? Understanding the difference between JavaScript and Python, right? Recapping, JavaScript requires you to use the I method, set the condition, and you would have to use the I as an index to try and grab that specific item, where Python's a little bit much easier. You can just grab that item specifically. And that's how you do that. Yeah, so if you want to not grab every single item and go within a range similar to how JavaScript does it, like I equals 0, while I is less than 10, I plus plus. If we wanted to do something like that, the way we would do it essentially is we can do for I in range, right? We're gonna do it in a range between a start and end point of a number, right? We want to get the range of what colors is. But this doesn't work, right? Essentially, the way this is going to work is in range of 0 to 10. Print All right, let's see how that works. If we're to do for I in range of 0 to 10, what it's going to do, it's going to start at that first number that you declared the range of, and it's going to do up to that second number. It won't do that number that you asked of it. It's going to be up to it, right? So as you see here, we have, it started from 0. It printed out what I is, because as they looped through it in the range of it, I became 0. It printed it I. And then it went to the next one in that range, which is 1. I becomes 1. It prints out I. And it does that up to 10. So that's how range works. So it works with a numeric value. And because it works in numeric value, we can't do for I in range of colors because it doesn't know what that range is. So very similar to how we do in JavaScript, we try to get the length of stuff. You need to use the len method, right? It's not length, it's going to be len for Python. And we're going to want to put colors in here. What this is saying is len parentheses colors, that's going to give me, that's going to return the length, right? We can essentially do that here real quick. We can do length of colors is equal to len colors, print length of colors, and it'll be 5. So 1, 2, 3, 4, 5. Not to confuse with indexes. You know how we choose index. We start at 0. This will start at 1. So remember that. A lot of people get confused with that. But we're going to grab length of colors. It returns 5. So that's essentially what this is doing. When we do length colors, it will return 5 for us. So it's going to be for I in range of 5. So if you're all still with me, this should print out in the range of that. So what did it give it? It gave us up to 4, right? So it starts at 0 and gets up to 4. It doesn't get up to it. It's in the range of it, but not, it won't print out that last one. So if you wanted to do exactly print out 1 to 5, then you would have to do length colors plus 1 because this will return 1 to 4. So 1 through 5, right? And that's how you would use that with the length of that specific array. By using range, bringing back the length. Everyone still with me? Any questions up to this point whatsoever?
I had a quick one, Roger.
What's up, brother?
So the list in Python, it's still a like a data structure the same way an array is in JavaScript. Like each like color would have an index value, right? That's indexed at 0.
Correct. Yeah, it just calls somewhat differently. There's actually some very technical definition when it comes to what is a list and an array. It's a little out of scope of this class for now. Don't overthink it, but essentially,
Okay.
JavaScript calls an array. That's what our list is going to be for Python. There is a difference of it. It's a little bit more technical than that, but it's out of scope for now. Don't worry too much about it.
Okay.
You can get more into it once you start the immersive for it. Just know that right now, the list is pretty much the equivalent of what array will be for JavaScript, right?
Okay.
And then you'll come to find out same thing when it comes to dictionaries, and what an object is in JavaScript. JavaScript calls it objects. We call it dictionaries in Python. And you'll see it just different syntax, different words, exact same concept. All right.
Okay. Sounds good.
Any questions so far, guys? Besides that? Cool. It's 7:36. Let's take our final break for the night before we come back and finish up the last hour. Let's return at 7:45. Right. Next thing is going to be breaking and continuing loops. So for num in range of 1 through 11, right? That should print out from 1 to 10. If num is equal to 5, we want to break. Else, or we don't want you have to put else. We can just print something. All right. So, what do you guys think this will do? If num is equal to 5, continue. If not, print. All right. What do you think is the difference between the first for loop and the second for loop?
First
Wait.
one when we reach the print statement, the second one will.
Yeah, exactly. Right. So, essentially, the break statement, the moment it reaches that type of condition, it's going to stop that entire loop completely, and it's going to return. Right. Whereas the second for loop, is going to reach that and it's going to continue. Do you think it's going to, actually, not exit back? No, yeah, you're right. Just like that. Any questions here so far? We can bring this bad boy out. We see here on the first for loop, it starts 1, 2, 3, 4. It reaches 5 and it breaks and it stops it. Right. The next one, it goes all the way through. Now, what if we were to do actually no, we'll keep it like that. We'll keep it simple. Yeah. So first one breaks it, it stops, it returns. If this was a nested for loop and it was inside another for loop, if this for loop breaks, do you think it would stop both for loops or only the one that's nested with the break statement? What do you guys think would happen?
It would just be the one it's inside of, right?
Correct. Yeah, it would just be the one inside of it. Just so you guys are tracking that. So if I were to be, for example, if I did for I in range of 27, print like, I had like a list of the alphabet and it was printing out every single letter. And then inside that, I had a nested for loop that said to print out a number from 1 to 27. But that one breaks at 5, then it would stop at 5, but the other loop itself will continue going. So it's whatever loop it's in, right? But what do we see on this one though? This one didn't break.
It skipped 5.
It skipped 5, right? Essentially what it did was once it reached 5, it didn't do anything. It just continued and passed over it, and it continued its loop like regularly. It didn't even get to the print statement, but it did not break the entire for loop. It just continued the loop itself. So that's the difference between break and continue. Essentially, you want the loop to continue. You just don't want it to act upon that specific item that you're looping through. You don't want to break it. You just don't want to work with that number in itself. And that's the difference between break and continue and its power. So depending on the situation, you might want to use one over the other. And yeah, any questions here so far? Cool. Nested loops. Oh, I knew it was coming. All right, so nested loops. So we're going to, if you guys are following along the slides, you can see that our example is going to be an animal list. It's going to hold dog, cat, and tiger. And then we're going to do a for loop. We're going to loop through this list of animals. We're going to do for animal and animal list. And that's going to initiate our first loop. So essentially what this is doing is going through our list. It's going to grab the first item, which is going to be dog, and we're going to do something with it. After it does that, it's going to go to the next item, which is going to be cat, and the next one's going to be tiger. But with nested loops, we're going to essentially run another for loop within that for loop, and we're going to say for letter in animal. So what this does, it's going to loop to the array, and it's going to grab every single animal in here. So it's going to grab dog first, then cat, then tiger. But then within every single dog or every single animal it grabs, we're going to run another for loop. It's going to be written the same way that we wrote the previous loops itself. But this one, we're going to, for letter in animal, my bad, typo. We're grabbing that specific item, and we're able to loop through a string itself. So we can actually loop through the string and grab every single letter in it. So we can do for letter in animal, we're going to print letter. And we can see that bad boy in action. It grabs dog first, and while it's holding dog, it's going to loop through dog and print out every letter. And once it's done printing out everything in dog, it's able to finish the loop. It's done with the loop, and it can go back up and go to the next item in that list. It grabs cat. It grabs cat and then initiates that loop again for letter and animal, and it prints out every single one and cat, and does that for tiger. All right, and this is how our nested for loops is going to go. Pretty plain simple, same syntax as its previous for loop. Nothing crazy, nothing too difficult. I think we're all familiar with for loops here. Next is gonna be another practice problem. This is gonna be the Python student practice number guess.py. You should be able to find that in your lesson. We have coins, number guess. Time is 7:53. Let's give it 10 minutes and return at 8:03. And this time I would like a volunteer to jump in and see if they can work through it with us. I'm not gonna lie to you. I forgot what time we're supposed to be back. Anyone finished it?
Yeah.
Okay. I'll give you guys 1 more minute before we come back. All right. Let's bring it in. Donnie, if you do not mind, let's see what solution you got.
Everybody see it? That's too small. All right. Can you hear me? Hello?
You're good.
Can you hear me?
Yep.
Oh, okay. All right. So starting out, import random to get the random module for the random number for the game. And then I just put a print statement just for the user, just to know what's going on. Then got the main function, and then I set a variable, a random num, using the random integer ranging from 1 to 100, and then start a count at 1, and then get the user's input for the first guess, and then I started a while loop. Basically, if it's not the right guess, then it'll go to break into a if else statement to see if the guess is high or low, and then it'll let the user know, and then it'll run the input again to get the user's input, and then increment count by 1. And then basically, whenever they get it, it'll drop down to this statement. And then obviously, if they got it first try, it'll print you got it in first try. And then if they don't, I use an S string to pass in count, and then it'll give you the number of tries. You need me to run it?
Yeah, you can.
Or 50, too high, 25, too high, 10. All right, got it at 10, 3 tries.
That's good. Yeah, so Donnie here, he imported the random module. You guys are able to do that. There's different modules that Python offers in the lesson. There should be a README at the bottom. There's like a link that sends you to the Python official documents. Or you can just also use W3 Schools. They have like different resources there you can find. There's different modules that Python has. So feel free to take advantage of them. Random being one of them. It lets you call a method that will return you a random number. That way you don't have to manually set it yourself. It's a very helpful tool. You didn't have to do that. It was a little bit out of the scope of this lesson, but good on you. Awesome that you were able to find that module yourself. But yeah, that is one option. I'll show you guys a little bit more simpler method if you guys were confused with the define and the main stuff and all that extra code that was in there. Not bad, Donnie. Just want to make sure that so we don't get too confused on it. So I'll share mine real quick. I did it while you guys were coding as well. You didn't have to use the random one if you guys couldn't if you guys didn't know that the random thing existed. But you're able to give it a variable yourself. That way you guys, because we haven't introduced a random mod yet, so I didn't expect you guys to use it. So you guys were just prompted to just give it a number, right? So this one was like, this one gave it -12. I gave it 12 itself. Here I put 1 equals false. Tries I started off at 1. And then while 1 is equal to false, essentially I just started a while loop. Very simple. I prompt the user for a guess, and then after that I did if else statements. Essentially, if it equaled the correct number, then I did one or two things. I checked if it was greater than 1. If it did, I would prompt them, or I would give them a return them a string that had the tries, right, for a much plural method. Let it know that they got it in so many tries. But if it wasn't more than 1, then I would just return it. You guessed it in 1 try, right? And then I changed the statement on the while loop to true. That way it would stop. Now, if they didn't guess the correct number, then I did 1 or 2 things, whether the guess was more or less than the number, and we just return too high or too low. Very simple. You guys didn't have to use the random module if you guys weren't aware of it, so it's okay. For those of you that did, Donnie, awesome work. But yeah, any questions whatsoever? Anyone did it differently than Donnie or I in any shape, way, or form that they would like to show the rest? Cool, awesome. Let's get back to it. We don't have too much time left. Screen. Why did I stop sharing? My bad. So that was the guessing game. Next, we're gonna cover. I see functions. Okay, cool. So functions. When programs get longer and logic becomes a little bit more complicated, it's gonna be harder to keep track of everything. Functions are used to manage complexity and increase reusability. Each function should be like should only be in charge of one thing essentially, right? Similar to JavaScript, we have to call it in some shape, way, or form. While JavaScript uses the entire name function to declare a function, Python is a little bit more simpler. That all you do is type in def for define, or you want to define a function. That's what the F really stands for. So we're gonna do def to define something. Can you guys see my VS Code before I keep moving forward? Everyone sees my VS Code or no? Just head nod.
Yeah.
Awesome. Yeah, so we're gonna do def to define it, and then after def, you're going to name your function, and we're gonna name some. What'd you do? Some. It's very common to use this to show functions to begin with, and we're gonna give it 2 parameters. We're gonna have num1 and num2. All right. Still very similar to JavaScript. Only difference is we're using def to define it. Colon afterwards. And then this is where we can start doing our work. We're going to do total is going to equal to num1 plus num2. I did something wrong here. Cool. So num1 plus num2. All right. Still just like JavaScript, whatever is in here, doesn't really matter. You can name this whatever you want. These are just essentially the parameters that you're going to have to pass this function for it to work. Inside the function itself, we have the actual work that's going to be doing, and then we want to return something. Right, that's the main purpose of our function. We want to actually do something and get it back. So we're going to return total. Now, afterwards, we can call this function. We can give it 2 different arguments, which is going to be, we'll give it 2 and 5. Now, what is it going to do? Is it going to show us what we want or no? What do you think is going to happen in my terminal after I run this?
Potentially nothing because it's not going to well, in this case, print, right?
Exactly. Yeah, it's not going to print anything. So make sure you guys are aware of that. Where is file? PD practice file. Okay. Python practice.py. So I call, I run my file. It does nothing because we're not printing anything now. So if I wanted to see what this is going to show, I would have to do print, and wrap it around my function, and it will show me what it has, right? Or I could have done, I could print it here essentially if I wanted to, but that's not really how you want to do it. So 2 and 6. 2. Yeah, the same thing. But you don't want to do it in here. You might as well just print it out here. That way, you let the work happen here, and then it should return you something. You want to print whatever it returns. You don't want to really do it in the function itself. So we'll do it here. All right, cool. So that's how we declare our functions. Just use the def method, and we want to return something. Next thing we're going to talk about is going to be scope. So the variables in a function are only going to exist in that function while the function is executing. Okay. When that function is complete and it's done running, those variables are going to essentially disappear, right? So if you were to declare a variable inside this function here, sum, and you called it like my dog's name, and you assigned it a name like Scooby-Doo, and then you try to call that variable later on, you're not going to be able to call that variable because that variable only existed in the scope of that function itself. So make sure you guys are aware of that. Example would be if I were to do num is equal to 12, and then I return num. Let's get this. And if I don't call that function and I just try to print num, as you can see here, it's giving me an error. It's not defined because this was defined inside of the scope of this function and not the overall scope of my program. All right, so make sure you guys are aware of that when declaring your functions. Default arguments. So it's possible to give a parameter a default value if no argument is passed in it in the function call. An example would be back to our num1 and num2 method. I could essentially assign a value to this, this parameter from the beginning. It could be assigned 10, and we can do return num1 plus num2. And then I don't have to define that argument. I don't have to give an argument. I can just do something as simple as sum and then pass the argument of 2, and it should still go through its function capabilities. It has a preset parameter already set. So because I set it here, I don't have to pass it in whenever I call this function. So be aware that that's an option of doing it. Now, what if I do pass it a different argument? So although I did set a default argument, I'm also able to still pass an argument here. And as we see here, line 110 return 4, because although 10 is its default value, I changed that default by passing it a new argument. That'll come into play once you start working with classes and stuff. Whenever you create an instance of a class, we'll be able to set some default values and stuff, and that's when it comes into very handy. But yeah, just be aware that you can do that. You can set a default value, and you can also still override that default value whenever you do call that function. So next thing, doc strings. Doc strings are going to be a special type of string that you should use to help document your functions. All right, so that's kind of what I've been doing here, like pseudocode. But there's a much mass-produced way of doing it. If you don't want to keep putting the hashtags or pound or whatever you want to call those after every comment, you can just essentially type in 3 quotation marks, and you should be able to write all the pseudocode that you like without having to constantly put the hashtags before it. This will help you to document your code as you're writing your program. You're able to, leave some documentation here to let somebody else that might be working with this document later on know what it does. Instead of having to read the entire function, you can, let's say this is a very simple function, right? This all it's going to do is going to add both these variables. What if there's a long, like there's like 20, 30 lines of code worth of doing something, and this is the first time I see it. Adding that documentation, this sums up the parameters. All right, will assist you to know what you're doing. This really comes in handy. Okay, so once you guys graduate out of the full stack immersive program, you're going to graduate with hopefully 2 full stack applications under your belt, right? And when you go to start applying for jobs, you're going to use your projects as a form of experience, right? Because unlike other software developers, you won't have that on the job training. You won't have that experience to show that you were working with a real company. So how are you going to let the employers know that you know what you're doing? It's going to be by your projects. Now, depending on where you live, the jobs that you apply to, if you're still in the military right now, it might be a couple months before you actually start applying to jobs. And if you're like me, who had like 2 months left after graduating from the full stack immersive program, there's a time between the time I started applying to jobs and the time that I had finished my project where I hadn't looked at my code for a while. So I had to go back, right? The previous week, the week prior to my interviews, I had to you know, go through my programs, read the code, and mess around with it to ensure I knew what I was talking about when I was demonstrating my projects to my employers. So, and they asked me like, "Hey, what does this code do, or where is this happening at?" I'm able to, navigate to that part of my program and knew what I was doing. And something that I wish I would have done was documented more of what my code did. So these doc strings are going to really help you out in the future. So make sure that you add that to your battle rhythm of your programming, right? Make it your norm that whenever you're coding along, you document what your code does. It would help you out in the future. Future you will definitely thank you. So if you find yourself, going through hundreds and thousands of lines of code in different files, that documentation is going to assist you to find what you're looking for. So it comes in handy, those doctrines. All right, so we have another student practice is going to be the hailstone.py, right? So you're going to write a function hailstone that takes in an integer, which is going to be n1, and it's going to print the hailstone sequence. So hailstone numbers, this sequence takes the name hailstone as the numbers generated bounce up and down to generate the sequence. Follow these rules. If the number is odd, multiply it by 3 and add 1. If the number is even, divide it by 2. Repeat until you reach number 1. So here's the sample input. So n1 starts off as 3. It is an odd number, right? So it's multiplied by 3. And it adds 1. So the next number should be 10, right? So 3 times 3 ends up 9. And you add 1, give you 10. And then that number now becomes even. So because it's even, it needs to be divided by 2. So we see the next number is 5. It is now an odd number. So it next is going to be multiply by 3 and add 1. And it's going to keep doing that until you reach the number 1. So your problem should probably have, or your solution, your function should probably have some form of condition that keeps running until it reaches number 1. And then depending on what that number is, you might want to do one thing or the other. All right. So that's going to be essentially your function. All right. You can see depending on the number, some are more complicated than others. It might take more running of your loops or whatever you're using to reach that final outcome. So time is 8:21. Let's take 9 minutes to work on this. And hopefully one of you guys finishes in time so you guys can present. And go. All right, let's go ahead and come back. Who finished the assignment? Awesome, David.
I got it, but I don't want to confuse nobody. So
That's okay. Let's let David give it a try.
Did my VS Code pop up there?
It did, and then it didn't.
Okay,
It's not-
cool.
Yeah, okay.
We good now? You see it?
Yep. Let's
All
see
right.
it.
So I just did N1 is an integer input by the user, right? And then the function hailstone taking in as its input that N1, which is an input by the user, a set of variable, which is a counter set to 0, and it's going to represent the amount of steps that it takes to take N1 to 1 using the hailstone kind of like algorithm there, and then set up a while loop while N1 is not equal to 1. If it is not even, you're going to multiply by 3 and add 1, and then add 1 to the steps counter. And then if it's even, if it N1 modulus 2 is equal to 0, you're going to divide N1 by 2 and add a step to the step counter, and then eventually return steps. And then when I called the function, I just said N1 because the N1 is the user input. So 3 should be 7, and it is.
Sweet, man. Yeah, awesome. Very straightforward. Yeah. Is everyone getting Python so far? Like, anyone confused? They feel like, oh, this is way too much. Like, anyone like scared, honestly? Or does everyone feel like warm and fuzzy? Like they feel they can do this and not too bad? Like, yeah, awesome. Yeah, man. Like I mentioned to you guys before, if you know JavaScript, you can pick up Python. Python is the easiest language you can start off with. So if you start out with JavaScript, you shouldn't struggle too much with Python. There are small little differences and stuff with the syntax. So obviously it's very easy to get confused. But for the most part, it's pretty straightforward. Okay, we got like a couple minutes left, like 15 minutes left before we'll stop for the night. So let me go back, share my screen. Uh, okay. Yeah, so we have that. We got Hellstone. Price of pie. Cool. All right, so next thing we're going to cover is going to be list comprehension. So list comprehension is going to be a concise way to construct a new list by applying some transformation to an existing list. It's going to be very similar to the map high order function in JavaScript. If you guys ever seen it, it's just like a very quick and elegant way to create a list. So I'm going to give you guys an example. This is straight off the slides as well. Nums going to equal to a list of numbers. So we're going to initialize a list and assign it which numbers, and then we're going to make a new variable called double nums. All right, and it's gonna be another list itself. And this is where list comprehension is gonna come. Essentially, you're gonna do all the logic inside the brackets themselves. And what we're going to want to do is we would like to loop through the numbers inside of our list nums here and create a new list out of those numbers, right? So the normal logic with this, if we weren't going to be using list comprehension, would look something like this. We want to create that a new list called double nums, it would be an empty list, and we could loop through the first list of nums. We could do for num in nums, and we could essentially grab every single number in there, and we would multiply it, and we would do new num or doubled num is equal to 2 times num. And so we would grab that number, we will multiply it by 2 and create a new variable called double num, and we would add that new number into our new array, or sorry, our new list, using the method append. All right, using dot append, we can pass it our new number, which is gonna be double num, and that will add it to our new list. And then we can print not only nums, but print our new array. All right, so after printing it, we see here that printing nums printed our original array, and then the new double nums, we added the formatted version of what the first array was supposed to be. Now, there's a faster way of doing this, and that's going to be list comprehension. So instead of doing all this mumbo jumbo, what we can do, which is going to be a little bit more elegant looking, is by doing all that logic inside the array itself. So we would essentially do 2, and we will multiply it by what would be nums. And here's where we can put all that logic we did here on the for loop, but in here. And it goes something like this. We multiply the num, because that's what we want to grab for nums, for num and nums. Now, this is the first time you guys see this. It might look a little weird. Essentially, this is calling that for loop for num and nums, right? It's the same logic we did here. That grabs that information, and this is where we want to have it at. And we're going to multiply it together, right? So it's a little funky, num for num and nums. It's almost like you're calling it twice, num for num, right? So it's a little strange when you first see it the first time, but this will essentially do the exact same thing we just did in this for loop from line 116 to 118, but inside this array. Essentially, it grabbed every single item in here and multiplied it, but we did it all inside the brackets. What is faster? It is the exact same thing. If the computer was trying to see time complexity, this is still the same as running a whole for loop. It's just less code and it looks pretty, right? So it looks very smart, but it is exactly the exact same thing. And there's another example we have here. We have only evens, right? We can do something like num for num and nums. It's calling the same logic we use above, right? But now it's going to be on the left side, right? Whereas in line 114, we had the logic on the right. We use the logic on the left, and then we're going to do something with that because this is going to return an item. By calling this logic here, num for num and nums is going to return that number. After receiving that number, we're going to do something with it. We're going to do modulus 2 is equal to 0, right? We're comparing it, and then it's going to return something from here, and we can print that out. Let's see what it returns. Print double nums. Or, sorry, my bad, only evens. For list and integers. For num and nums. Oh, my bad. If num. Okay, here we go. So the first one on line 114, it wasn't like an if or else statement. It just straight up grabbed the item and it manipulated it. It did something with it, transformed it, and returned it to double nums. On line 115, we did something different. We actually did a whole if else statement, right? We called and we looped through the list on line 113, which is assigned to the variable nums. And after grabbing every single item, we checked something. We checked the condition. If that specific number modulus 2 is equal to 0, we want to return it and add it into only evens. If it does not pass that check, it did not take it and add it onto only evens. So as you see here, it looped through the first one. It checked number 1, and it's checked if that number modulus 2 is equal to 0, then it would add it in here. If not, it skipped it. And we see that it didn't add it. It went to the number 2. It grabbed it. It passed that check, so it added it onto only evens. It moved on through its list comprehension. It checked 3, did not pass that check. Got to 4, it passed it, so therefore it added to only evens. And it did it all the way through the entire list. And it created that new list, only evens. Pretty cool, huh? Did I lose anybody up to this point? Awesome. Very powerful. It's just a fancy way of doing it. It's the exact same thing that you would do in the for loop. It's just on the line itself. It looks fancy. But that's what list comprehension does. But it's not new to you guys if you ever have to see it again. Next is gonna be dictionaries. We'll cover this real quick before we finish for the day. So dictionaries is a data structure that allows you to store key value pairs, right? This is very similar to what JavaScript has, right? One of the most useful data structures in the algorithm challenges. And the reason for it is because unlike lists or arrays, where you would have to either loop through the entire array or list, or you would have to know the index of the item you're looking for, you can use specific methods on the dictionary where you can either call the key itself or you can check if it's in there, thanks to the key value pairs. A lot more simpler instead of having to loop through every single item in an array, right? And the way that it's going to be declared is very, very easy. Just like everything else that we've declared are not variables, we're just going to go ahead and call it. We're going to do the example of the slide, which is going to be state capitals. All right, that's going to be the name of our dictionary. And we're going to start it using the open curly brackets and close brackets. That's going to initiate the dictionary, right? Just like JavaScript, it requires key value pairs. We're going to grab a state, and it's going to be Washington. Using the colon, we're going to assign it a value, which is going to be our capital is going to be Olympia. I'm not gonna lie to you, I didn't even know that was the capital. But cool. Next is gonna be the next one's gonna be Oregon. We're assigning it a value of Salem. And after every key value pair, you're going to separate it with a comma. Next one, we're gonna give it a key of Idaho and assign it. Ooh, my bad. Idaho. And we're going to assign it boys. Capital, apparently. Oh no, my geography is horrible. Okay, and this is essentially our dictionary. Other dictionary we can do say like alphabet is equal to A is gonna be the first number in the alphabet, B is gonna be the second number in the alphabet. We're able to give it numbers and so on and so forth, right? By key value pairs. And now how do we access these items? Well, we can use our print method. I'm going to call the dictionary. We'll start with state capitals. And we're going to what we call bracket notation. We're going to open up, after calling the name of that dictionary, we're going to open it up with brackets. And in here, we're going to put the name or the key of our dictionary. And what that's going to do is going to print out the value assigned to that key. Now, if I'm correct, there's also no annotation. I'm mistaken it something else. Okay, I'm probably thinking something else. But yeah, so we'll use the bracket notation. We're able to directly call that key for our state capitals, and it'll return us the value of it. If we wanted to delete something, we can. All right, we'll ask it first. Let's say we want to add something new. We can do something like state capitals. We would call the name of the dictionary. We'd open up the bracket, and then we will assign it the key that we want to assign it. Let's say we're going to do Texas, and we would do equals to assign it a value. And we do Austin. All right, and that's how simple it is to add something new to that dictionary. Where you call the dictionary, you assign it a key. Right, it can be whatever you want. We can give it Texas, and then equal, therefore assigning a value to it, and it can be Texas. And that should add something new. We can even print it out and see what our state capitals look like. Washington, Olympia, Oregon, Salem, Idaho, Boise, Montana, Helena, Texas, Austin. If we no longer wanted something out of here, we can do DEL for delete. Call the dictionary again, right? We're calling the dictionary. Using the bracket notation again, we would call whatever, my bad, not the value, key. We would, what am I doing? Print it out. Okay. So we added Texas and Austin. We printed state capitals. We see that it printed out, and then we deleted it and printed once again, and it's no longer here. So we can see that this is how we add, and we can delete different items out of our dictionary. Now, what if we want to grab all the keys or all the values or all the key pairs out of our dictionary? Well, there's a very easy way of doing that. So let's go ahead. Let's delete these print methods. And we can do something like looping through them. We can do something as for key, right? And state capitals. And there's certain methods that it comes with. It comes with the dot keys, dot values, and dot items. So if we wanted to grab all the keys, we would do dot keys, opening close parentheses. This is a built-in method that it comes with. And we can print key. It will loop through every single key, assign it to that variable key, and then we can print it out. If we run this, it prints out every single state assigned in that dictionary. If we wanted to do values, we could do the same thing too. For value in state capitals, we call the method dot values, and it should print out every value. I think up to this point, JavaScript and Python are very similar. The only one that's different, I think, is its key value pairs, where in JavaScript, it uses entries. In Python, it's going to use items. We're going to do for parentheses key value in state capitals. We're going to do dot items, and then we can print key and value. And it'll print out both the key and the value, right? So not to get confused with JavaScript, which is dot entries, Python is going to be dot items. Everyone still with me up to this point? Good. All right, that's pretty much a quick intro to dictionaries. Very similar to your JavaScript version. Very small differences. It's 8:50, so we're gonna cut it here. We'll stop the recording and I'll open it up for any questions.